In this video, we investigate the sources of new energy on Earth, answering the question, where do we get new energy to use every year? As it turns out, we get almost all of our new energy from the sun. Solar radiation accounts for 99.98% of the Earth's energy budget. That's almost 100%. 47% goes to heating the atmosphere, land, and the oceans. 30% is reflected back into space. 23% drives the hydrological cycle of evaporation, clouds, and rain. A scant 0.2% creates wind and waves, and an even smaller amount is used for plant photosynthesis. Aside from the sun, heat from the center of the Earth accounts for about 0.02% of new energy on the surface. Gravitational tides from the moon and the sun account for only 0.002% of new energy. And volcanoes and heat springs bring in only a tiny fraction of new energy. So we see that the sun is far and away the greatest source of new energy on Earth. But what, you ask, about fossil fuels like coal and petroleum? Don't these contribute to new energy? Well, as the name implies, fossil fuels are very old energy. Fossil fuels were originally organic chemicals created millions of years ago by green plants using photosynthesis to combine sunlight, carbon dioxide, and water into their physical structures. These plants were eventually buried for millions of years, where they were converted to simpler hydrocarbons by high pressure and heat. Coal comes from land-based plants, and crude oil and natural gas come from ocean-based plankton and algae. So the origin of fossil fuels was solar energy stored in plants millions of years ago. You can think of fossil fuels as ancient liquid sunshine. Fossil fuels are a dense source of energy. They revert to CO2 and H2O when burned. The H2 water is harmless, of course, but CO2 has become a major contributor to global warming. Thus, burning hydrocarbons, especially coal, creates other pollutants such as sulfur dioxide that contributes to acid rain and nitrous oxides that contribute to smog. Finally, fossil fuels are ultimately in limited supply and are increasingly costly to procure. Hence, this motivates our interest in other reliable sources of new energy on the Earth, which we call renewable energy. The graphic on this slide shows the relative quantities of renewable and non-renewable energy sources available to us annually. The giant yellow sphere, of which we only see a part, represents the solar energy that the Earth receives each year. On the right, the smaller spheres represent the amount of energy we can derive from non-renewable sources if we use it at a rate that would deplete it in just 30 years. Coal is the largest reservoir of non-renewable energy, followed by uranium, oil, and then natural gas. On the left, the spheres represent the amount of renewable energy available to us each year. Besides solar energy, the largest is wind, followed by biomass, hydroenergy, geothermal energy, wave energy, and finally tidal energy. In the middle, we see current annual global energy consumption. Looking at the details, only coal would last longer than 30 years if it was our only energy source. Also note that only wind and solar could individually supply all of our global energy needs far into the future. Solar energy alone can supply thousands of times what we require. More energy is available from the sun in an hour than humans use in a year. It's little wonder then that most of the attention on renewable energy sources focus on wind and solar sources. Two other questions that naturally arise are, what are our sources of energy today? And how is this energy used? This busy graphic answers these two questions. On the left, we see sources of primary energy. In descending order of energy supplied are petroleum, coal, natural gas, biomass, nuclear, hydro, geothermal, wind, and solar, the latter growing rapidly. On the right are end uses of energy, which in descending order are industrial uses, transportation, residential, and commercial uses. Pause the video for a moment to examine the details of this graphic. It's pretty interesting. This next graph shows the history of energy use over the past 4 decades, from 1980, and forecasts for energy use over the next 3 decades to 2050. Several things to notice. Total global energy use is forecast to peak about 2030 and then to start to decline slowly thereafter. Global coal use is at its peak today and will decline significantly as will energy from oil. Energy from natural gas, nuclear plants, biomass, and hydro are forecast to remain relatively constant to 2050. Most significantly, solar energy and wind energy are forecast to increase rapidly over the next decades to become significant contributors to global energy. Given the rapid innovation with wind and solar sources and their rapidly declining costs, these projections may well underestimate the future contributions of wind and solar. Summarizing, of the new sources of energy on Earth, almost all of it comes from sunlight. Other sources are negligible. Fossil fuels can be considered as stored sunshine. Fossil fuels are inexorably declining in supply and are sources of carbon dioxide and other pollutants. Renewable energy sources of energy are far larger than non-renewables over time, with solar the largest by far and wind in second place. Renewables are forecast to be a rapidly increasing source of energy in the next decades. In the next video, we'll take a closer look at the sources of renewable energy here on Earth. We'll see you there.